are recording. There's donuts up here if you want some. Miss Morrison, right?
Yes, sir.
Okay, there's donuts right there if you want some. All right, we're on page 294, and we are starting 5A. And y'all need to tell me what to go to after this, because I don't know what to go to after this, because I don't have an outline in front of me, and this book is weird. So we'll just go the best we can. All right, first thing we need to talk about is statistics. What is statistics? There's two words now. There's the same word but different meanings. Whatever, is that homophobe or what is it? Well, not homophobe, homophone. What's it called? A homophone?
Homophone.
Okay, homophone, homophobe, whatever. A homophone, basically the capital T stands for the science of collecting data and calculating data. Calculating, obtaining, and calculating data and interpreting. Lowercase statistics is, don't say it right there, but lowercase statistics starts with an S, lowercase s. That's basically a parameter for the sample. Write that down, a parameter for the sample. So uppercase statistics is the science of collecting, organizing, and interpreting data. And lowercase s is basically a parameter for the sample. Now, a lot of times, well, let me go ahead and tell you this. 20% of your test is going to come from the reading portions of chapter 5 and 6. All right? I think most of the reading is in chapter 5. The 80% of your test is going to come from the math section. Now, when we get to the math section, that has to do with calculating z-scores, it has to do with finding the mean and the standard deviation, and it has to do with drawing the area under a curve. So you'll know when we get to the mathematics portion, and that's going to make up 80% of your test. All right? 20% of your test is going to come from definitions and vocabulary, and that is probably going to be one of those. You need to know the difference between the two. When we get to lowercase s, I will tell you the biggest difference between them. But right now, you just need to realize that uppercase s and lowercase s. Uppercase s is the science. Lowercase s is a parameter or a variable for the sample. Here we go. Population. The population is always the bigger group. Population is always the bigger group. So if I tell you that the population is Tri-County Technical students, then a sample could be Anderson campus, or Oconee campus, or Easley campus. Okay? Why would I not use Pendleton campus as a sample? Because Pendleton campus makes up about 75% of the population, so we kind of like to be doing a big sample, which the whole purpose of doing a sample is for time and what? To save time and money. Now I'm using Tri-County Tech, but let's say you're an executive you're the quality assurance director for, or vice president in Michelin Corporation. And you've got you a VA office up there at Crystal Palace, right above Greenwood on 85. And you bring in $125,000 to $175,000 a year, and you are responsible for the plant in Greenville, you're responsible for the plant in Sandy Springs, you're responsible for the plant over here in Anderson, you're responsible for the plants all over the Southeast. Okay? You're paid to watch how many bad tires come out of the plants. So your population is the Southeast plants. That's your population. So you decide, well, I'm going to go to the Sandy Springs plant, I'm going to pull 500 tires, and we're going to see if they're bad or not. And you're going to use that sample for the Southeast. All right? The sample is Sandy Springs. The population is the Southeast. Everybody with me? The population is always your bigger entity. It's always your bigger number. Okay? Now, when you're dealing with the population, okay, now this is where you get into if you're in a presentation and you need to know your stuff so you don't sound ignorant. All right? Let's say that you're in a population, you're in a meeting, and somebody's presenting to you the population, and they throw up mu and sigma. Well, mu and sigma are both Greek letters. Greek letters are population parameters. Write that down. Greek letters are population parameters. If you got a book, you need to highlight population parameters right there in the purple. Population parameters. Variables, right here. Variables that usually are Greek letters that signify the population. So if you're sitting in, let's say, I don't know where, who has a job somewhere? Somebody tell me, okay, where do you work? Interim healthcare, that's a good example. I was going to use the hospital. All right? In interim healthcare, let's say that you're a nursing assistant or a nurse or a doctor or whatever, and you have a departmental meeting, and in that departmental meeting, some outside company came in and did a summary of your floor or your department. And they basically said, well, the population age is mu is equal to 68. But X bar is 62. Well, X bar is the parameter for, it's called the statistic, little s, of the sample. So if you see a letter like X bar or S, then you know it is a parameter for the statistic. S, lowercase s. Okay? If you see mu or sigma, which is a Greek letter, you know it's the what? The parameter for the population. No sneezing, please. You can't sneeze, yawn, or cough. Just breathe. Okay. All right. So, if you're in a meeting, and this is the only reason you need to know the difference between parameter and statistic. If you're in a meeting and they're showing you mu and sigma, mu and sigma, mu and sigma, then you know not to say anything about the sample because they're talking about the what? The population, the parameters for the population. Parameters is another word for variable. Okay? Parameter is another word for variable or letter. What letter or variable are you using? I'm using Greek letters, so therefore it has to do with population. Well, if I'm using regular letters like S and X, then I'm talking about the what? The sample. So if I go back to my Michelin story, and I show you, and I'm presenting in this meeting at the Crystal Palace up there to all the presidents, and I'm saying, okay, we went and we got the population of 68 tires. Okay, population of the Southeast, mu is equal to 68. And X bar is equal to 27. Then you know that the 68 has to deal with the Southeast, and the 27, or whatever I said, the second number, has to deal with the Sandy Springs plant. Because I said X bar and I said mu. Population, same. Okay? There's no real math knowledge here. This is just knowledge. So if you're presenting or you're being presented to, you know the difference and you don't raise your hand and sound ignorant. That's basically why you need to know the difference. All right? Because nobody in here is going to take this class and go out and become a quality assurance manager for a company just by one statistics course. That's not going to happen. So most of the reason for some of this stuff is just so you don't sound ignorant when you raise your hand and say, what's mu? You don't do that. Okay? You just, as my grandfather used to say, keep your mouth shut, you don't show your ignorance. Well, sometimes you need to keep your mouth shut. All right? But this is a good time, this is a good aspect of a meeting or a presentation that you say, okay, they're saying mu, so they're talking about the population. And X bar, they're talking about the sample. Okay? And the sample is always smaller than the population. Capiche? Comprende? Or comprendo? Comprende? Whatever.
Yeah.
Y'all settle down.
Conjugate.
Huh?
They're conjugate.
Okay, whatever. Comprenda?
Yeah.
Comprend, huh? Comprenden? Comprende is when you're talking to one person, right?
This is like issue. Comprende just
Dang old Spanish. All right. Next page, I'm not going over that. Population, there you go. Population sample, there you go. Random sample. Let's say I have a goldfish bowl. And I put each one of your names I give each one of you a red pen. And I tell you have to use a red pen. And I take a Post-it note and give you each a Post-it note. And I tell you to write your first name, middle initial, last name, fold it in half, and put it in a fish bowl. Okay? That is a random sample. Why is that a random sample? Wow. Did you actually read? Or how did you know that?
Psychology.
Oh, psychology. Okay. You cheated. All right. Now, what if Miss Fox decided she didn't want to use the red pen? She wanted to use blue pen, and she didn't fold hers in half. She folded hers in quarters. Is it a random sample? No. Why? Because when the person is picking out of that fish bowl, and they feel everybody's is the same, it's a random sample. But when something is not like the ordinary, or something is not like the rest of them, it changes. So that one person folding theirs different, it's not a completely random sample. A random sample is when everybody is the same and everybody has the same exact percentage of being picked. So everybody would be a simple random sample if they follow directions and not use a different pen or folded it different or used a different color Post-it note. Okay? So the main thing you've got to remember there is everybody has to be consistent. Everybody has to be uniform and everybody has to be consistent. Therefore, they have the same chance of being picked. Okay? Same thing with throwing a dart in the balloons. You know, at the fair, everybody throws a dart in a balloon. All those, that's a simple random sample because you're throwing at a board that has a balloon in it. If you hit one of them, each one of them has the same amount of chance of being hit, or the same calculated value of being hit. So it all depends on where you aim. All right? Systematic random sample. If you can't do a random sample because of too many, your best bet is to do a systematic random sample. That's your best. That's your second best sample. Why is it the second best sample? Why would you want to use a systematic random sample versus a random sample? Well, a random sample, think of a random sample like all the people in the phone book. What's wrong with all the people in the phone book? A lot of people, you have to write every single one of those people's names down on a Post-it note with a red pen and put it in a fish bowl. Now, what if you was to pick every last person on the page? That would be a systematic random sample. So you go to the bottom right-hand corner of every page and you pick that person, front and back. So bottom right on page 4, bottom right, Smith. Bottom right on page 65 or whatever, the next page, bottom right. Next page, bottom right. And you write every one of those people down and put it, then you not only do you not have as many people, but you have a random sample. It's just systematic. Every fourth person. Let's say that I go out in the parking lot and I chain up all the gateways except for that one gate out there, and I pick every fourth car that comes out of the parking lot and ask them if they like a certain TV show. Okay? That's a systematic random sample because I'm picking every fourth car that comes out of the parking lot and there's no other way out except for through me. And I gotta ask that question to the fourth person. Versus, what would it do, what would happen if I asked every person? Somebody gonna be mad because what? Traffic is backed up. And then systematic random sample, you basically do every fourth car or every 10th car or whatever. Now, what would make it not a systematic random sample if you didn't choose every 10th car? Oh, I'm getting tired of this. I'm just going to pick the next 5 cars. You just blew it. Okay? You have to be consistent throughout the whole thing until the last systematic random sample leaves. Let's say you're on the last 15 cars. Can you do 2 more 10s or can you do just 1 more 10? You do 1 more 10. The other 5 just go. Okay, you're not gonna do, oh, I'm gonna get the last part. No, you don't have, if you've got the last 10 and there's 5 cars after that, then they just go. If you have 10 cars after that and then there's no more cars, you've got to get the last 10, that last 10th car. You got to be consistent and you got to be uniform whenever you do anything having to do with research or anything having to do with statistics. Okay? Because that gives you neutrality. And what is neutrality? Down the middle, neutral. Think of a perfect example of neutrality. What's a perfect example of neutrality in today's society? They wear striped uniforms. Referee. Referee is pretty neutral because they do not care about the team. They don't care about this person versus this person. Unless you're a Clemson fan, and then everybody's against you. Okay? No remarks? I figured I'd get something. Nothing.
So a quick thing about the use that I said, for example, you said about how would that be confounding?
What now? Say again? I didn't hear but half your question.
So when you use for an example of people voting and whatnot, would that be called confounding?
Yes, it would be. It could be considered that. If you change the simple random sample in any way, yes, that's in some cases it's called confounding. But that's a little bit more advanced than what this book goes into, because this is more of an introduction, but yes, that's what it's called. And your psychology will cover that, because if you change it in any way, you're basically, you're disrupting it, and you're changing the neutrality. Convenient sample. Here's an example of a convenient sample. I'm a DJ at a rock station, okay? And I call out, and I'm on the air from 5 o'clock in the afternoon until the 5 o'clock to 11 o'clock at night. And I say, okay, listeners, I need to take a poll. How many of you like rock music? Now, what's wrong with that?
But it's a rock station. Of course it happens.
But I'm doing a sample. But it's convenient. Why is it convenient? Because I already listened to me. I've already got 5,000 people to pull from, but I'm skewing it because why do I even go over convenient sample? Because I want to give you an example of one that can be the least accurate, and that would be the convenient sample. Be careful if you do a convenient sample. And that's just, in the near future, if you ever are, like in a psychology class, you may be told as a group project to go out and ask how many people in the Marlboro Club, or how many people drive a white car, or how many people, watch movies on Fire Sticks, or whatever the case may be. Whatever the group, whatever the group comes up with a survey, you need to know that the convenience sample is probably your least accurate. All right. Me going to work out at a gym and asking people how many of you smoke. Okay, again, that would not do that, because even though there's a lot of people that go to the gym that smoke like a freight train, it's still, you wouldn't want to do that because that's skewed the other way, because a lot of people that care about their health and go to the gym don't smoke. Okay? Now define smoking. Then you need to define smoking. Does that mean, social smoking, or does it mean like 5 packs a day eating cigarettes? Okay, that's two different, you got to think about it. You want to say in your survey, social smoke versus eating cigarettes. Oh, sure. All right. So stratified. Stratified is when we're talking about grouping. Grouping is be like, I'm going out and I'm going to find out how many people voted for this person, how many people voted for this person. So I go out to blah, blah, blah precinct, and I know I'm going to have stratified. Why? Because with any election, there's going to be 2 different what? Or 3 different what? Parties. There's usually the Democratic Party, the Republican Party, and independents, and other. Okay? Now somebody's going to say, oh, my department head today said I talk too much about politics. Well, it's very difficult not to teach in a statistics course and not mention politics, because stratified And group samples are usually done in a political setting because there's Democrat and Republicans, there's male and female, there's different age classes. So you have everything wrapped up in a precinct. That's why a lot of people go to precinct, and it's called open polling. And that way, they can predict who's going to win the election. Well, they can predict who's going to win that precinct by doing the open polling. When people come out, will you take a poll? Yes. Who'd you vote for? I voted for this person, this person, this person. Okay, thank you. And write it down. They didn't write a name down. They didn't write, they just wrote this, yes, and yes, or whatever. And then they take that data and they go back to the newsroom and say, okay, this person's going to win this precinct. You see what I'm saying? It's called open polling. So it's very difficult to mention, to talk about polling and talk about sample methods and not mention politics, because it's one of the biggest things that's out there. If some of you watch the news, you actually have people that do nothing but have businesses, and what do those businesses do? Take polls. There are a lot of people that's gotten rich off of taking polls. All right, I know 2 or 3 right now that come on the news, and that's all they do. They just talk Rasmussen. Rasmussen, Mr. Rasmussen, or whatever, he has the Rasmussen poll. He don't do nothing. Okay, he just has people go out and do polls. But they have to be what? They have to be non-biased. That's the problem. That's when you get into a lot of discussion about polls, is when you talk about bias and being neutral. We're going to talk about that in just a minute. And we talked about that. So you need to write those 3 or 4 down. Basically, out of those 3, sample random, simple random, and convenience. Make sure you know those. Do you understand? And there's pictures right there of the 3 or 4. And I'm not going to go through that because I just went over it. And there's a caveman. There's a picture of a caveman. I don't know what that has to do with it. But oop, there's the word homo. Oh, God. Hubert said homo. Oh, there we go. Bias. What is bias? Well, either on personal or you lean to one side. Now, I said that in one class. I said whether you lean to one side, and somebody complained to my department head and said I was being political. I said lean to one side. What could that be? Could be anything. Yeah, could be. Lean to one side or go to one side of the white line. Okay. Oh, he said white line. Oh my God, you were talking about drugs. I mean, I can't win. But you know what gets me is these psychology and history teachers, they can talk about anything they want to. And I say one thing and talk about weather, and I get in trouble. God, I'd hate to be a psychology teacher. I'd probably get in trouble every other day. But anyway, watching out for bias. Bias is when your judgment is affected by your own personal feeling, like you said. Now, you can name out a lot of bias. Let's say that you're executive who? R.J. Reynolds. Now, what's R.J. Reynolds? Tobacco company. They make cigarettes. Okay? And they do a survey on whether cigarettes are unhealthy to your health. Okay, now is that going to happen? Is that going to be an accurate survey, do you think? Hell to the no. Okay, it's not. Now, what if you have an outside company? Yes, like Rasmussen. Yes, Rasmussen would be, and Rasmussen is one of those polls that they have a very good record of being down the middle. Right down the middle. So if you get a Rasmussen poll, and the Rasmussen poll says side A is popular to side B, chances are it's correct. Okay? And we also talk about margin of error and N. Now I'm going to talk about a Republican debate that happened in 2016. And a poll that came out right before the debate came out. And it was it was kind of a weird thing that was happening. The media was finding out that Jimmy wasn't going to be the next president of the United States, Jeb Bush, because he couldn't even get his foot off the ground. Okay, he couldn't even get the 1% of the vote. All right, so there was a problem going on. Bush is not going to be our Republican nomination, so they had to find another candidate. The media and the Republican, I'm talking Republican. I'm not talking about Republican versus. So I'm talking about Republican. And they were scrambling to find a new candidate because Jeb wasn't going to do it. And they couldn't get Trump in there because Trump would destroy the world. So they had to find it. So what they did is they went to Ted Cruz. All right. They said, okay, we're going to put our stock in Ted Cruz. And there was about the third debate that was coming up. All right. They just pretty much realized that Jeb wasn't going to do anything. So they lost confidence in Jeb. So they had to have a new poster boy. So they went with Ted Cruz. And the day before the third debate came out, there was this poll that came out. And it was a crazy poll. It says that 78% of the population is going to vote for Ted Cruz. And all the other polls had been coming out 25% for Trump, and the rest of them had like single digits. Well, there was like 18 people in the. Y'all remember? Some of y'all remember 18 people? It was 18 people running for the Republican nomination against Trump. 17. All right, so it was 18 in all. And Cruz had 75% of the vote, and everybody looked cross-eyed at that poll. Well, down at the bottom, the two things that make a lot of difference on a poll. Can anybody name them? They're in the little fine writing down at the bottom. Ian, how many people surveyed, and the margin of error. The margin of error needs to be at least 3 or less, 3% or less. And Ian needs to be a good number if you represent the United States. Ian was 100. Ian was 100, not 1,000, 100. And the margin of error was 7%. So somebody tell me what that poll was. It was biased. What was it trying to do? It was trying to sway the debate that's coming up the next day. It was trying to sway support from Jeb to Cruz. Now, a lot of you say, well, he's just a conspiracy theory. No, there is a thing called suppressive polls. What is a suppressive poll? Does anybody know what a suppressive poll is? A suppressive poll is a poll that is put out to get you as a consumer to think like the poll. Okay? There are those out there. That's why when you're talking about polls and you're talking about decision making, okay, I'm not talking about voting. I'm talking about whether you use Tide or whether you use Game. All right? You have to do what? Your homework. You have to do your research. Okay? You don't just take, and that's what's wrong with a lot of our society today. Our society reads a poll or reads an article and they just believe it. They just believe it. They trust, 100% trust in the media or the magazine or the article or whatever. They just trust it. And half the time, some of the time, it's not what? It's not real. Okay, so you got to watch it. And a lot of people say, well, you're talking about the politics. No, I'm not. I'm talking about any source of information you get. How many of you have read something on Facebook that's not true? How many celebrities have died? Name some of the celebrities that are dead and not dead. Sylvester Stallone was one. He was one that said died in a plane crash or something. And he was dead. And he's not dead. Huh? Who? I didn't hear you. Betty White, yeah, she's like 107. Yeah. So Betty White, and she's pretty cool when you're doing it. You see the interview with her, she's pretty cool. But the whole point is, whether it's politics or whether it's Tide versus Game or whether it's Betty White or Sylvester Stallone, you cannot accept what the media says. You have to do your research. You have to go back and say, Snopes, go to Snopes. Okay? Even though Snopes can be, you gotta watch Snopes too, because sometimes they're a little bit And that's why you always, how many times have you been told on a midterm or a term paper to just do one source? I just want you to go to one source. No. Why do they not tell you to go to one source? Exactly, because you need to pull from different sources. That's true with information, period. And when you're talking about statistics, you need to pull from different sources, and you need to make sure that you're not being biased at all. That's why when you put out a survey, if you put out a question, you don't smoke, do you? Versus, do you use tobacco? All right? Which question is right for a survey? Do you use tobacco products? Why don't you don't smoke, do you? It has a what? It has a negative connotation to it. And I'm talking even with the questions you put out, you can't be biased. You can't be biased with the questions, you can't be biased with the data, and you can't be biased with the interpretation. It's right down the middle. And that's why that word right there, bias, that is one of the, make sure you write that down because you will see that. All right? Bias. You cannot be biased when you're dealing with statistics. And next time you see and there's the definition right there. The next time you see a poll in a magazine or a newspaper, especially around election time, look down at the bottom and look what the N is and look what the margin of error is. If it's 3 points or more, just crumple it up and throw it away because it's not worth the paper it's written on. And if the N is 100, throw it away because it's not worth it. And you'll see there's a lot of suppressive polls out there trying to get you to vote for this person or trying to get you to use this product or trying to get you to use this business. They're out there. And some of them are just fake. Some of them put a poll out that says 78% of the people eat at Rockin' Joe's hamburger joint. And then you look at the data doesn't even make sense. They're just making it up. So, types of statistical study. Observation versus experiment. Probably, but we'll look. Yep. Write it down. Observation versus experiment. Somebody give me an example of observation. What's an observational study?
Were you saying that your observation or make a...
Huh?
Are you saying that you're not...
No, give me an example of an observational study. I'll give you a classic one. How many of you have ever seen those videos of people sleeping, like a sleep apnea? So they're always in dark, green, the what do you call the camera that you can see in the dark? What do you call it? Yeah, no, night vision. It's the night vision camera, and the person is always green with blue eyes or yellow eyes, and they just sit up in the middle of the night and they got all these things on there. That's an observation. Why? Are you doing anything to that person? You have that person in electrical current? No. Why does he get up? Well, they're having sleeping disorders, okay? A sleep disorder video, that's an observation. Because you are doing nothing but sitting in a bed and sleeping. Now, what if I decide to divide this group up into 2 groups, 4 here and 4 here, 5 here. And I tell you to go home and eat regularly, but take this blue pill. And this blue pill is going to make you lose 10 pounds in a week. And I tell you to go home and go on a diet, and I give you a red pill, and the red pill is just a sugar pill. Okay? Doesn't do anything. Is that an experiment or observation? It's an experiment. I have control. I am controlling. I am manipulating. I am having something to do with you in the study. Okay, I'm giving you a pill, and I'm telling you what to do. I'm telling you what to eat and what not to eat. That's an experiment. So if I do the if I do the observation with the sleep apnea, and every time a person sits up or wakes up, I shock them with electrical current, is that an observation or is that an experiment? That's an experiment because I'm interjecting something into that observation. So once you interject something into or insert something into an observation, you are making it into an experiment. Okay? Y'all sure are quiet. Go ahead and write down placebo. One of my favorite shows is called The Andy Griffith Show. And it's not one of my favorite shows, but I have trivia games, trivia cards, trivia books about. So if anybody ever wants to try to play me an Andy Griffith trivia, I'll be glad to take you on. Nobody will play it. So I don't get to play it very much. But every now and then somebody will try it. And about the fifth or sixth question they quit.
My dad
So-
might try.
Huh?
My dad might try.
Did Andy Griffith nut too?
He watches it all the time.
Oh, I do. I'll watch it. Even if it comes, if it's reruns, I'll watch it. Whatever. I don't watch the colors. I don't watch the color version because Barney's not on. But he was in 3 color versions. He did come back to visit Mayberry in 3 episodes. But anyway, why did Barney leave the Andy Griffith Show? He went to work for Walt Disney. That's why he left the Andy Griffith Show. And he ruined the show when he left. Because it was not funny after he left. But anyway, in one episode, Emma Brands is an old lady in the town. And she jaywalks because she's like 120 years old, and the sheriff don't ever do anything about her jaywalking because she figures one less step is one more day that she'd be around. Okay, maybe she is one over by train or plus, but evidently it's okay for Emma. So Emma goes by the drugstore every week to get her pills, and the drugstore owner is a friend of hers, and he gives her the drugs for a bottle of pills for $1. Okay? Now this is in the 60s, okay, so the dime, you know. So the Fred is the drugstore, he's the pharmacist. Fred has to go on vacation or has to go out of town, and his niece is running, she's a pharmacist. She's running the pharmacy. And Emma comes by to get her pills, and the pharmacist says, "What pills?" Well, Fred gives me my pills, and they're $10, and I come by and get them every Monday, and I come by the next Monday and get them, and they're right here, and I put my dime down and I get them. She said, "Well, I need to send you a prescription." So the whole show is about Emma getting sick and going to her deathbed on the show because she can't get her pills. And Andy Griffith tried to persuade the new pharmacist, the niece, to give her the pills because she's going to die. Well, the whole town ends up sending her all this food because she's going to die. Y'all never seen this episode? Y'all need to watch Andy Griffith. It'll help you out.
I've seen the show, but not that episode.
Okay. Yes, I think it's second or third episode. Anyway, there's 249 episodes, 159 of Black and White. All right, so this is the 3rd episode. And anyway, make a long story short, in the last 5 minutes of the show, the pharmacist brings the pills to her. She's laying on the couch with a turkey leg in one hand and a piece of cake in the other hand. And she's feeling terrible. She don't know if she's going to make it. And the pharmacist comes in and gives her a pill. She said, "Here, take 2. And she takes 2 pills and kind of goes black and comes back to the den, and she's feeling better. She's eating and she's feeling better. And the pharmacist said, "Well, I hope you feel better, and come back next week and get your pills." And they go walk outside, and the sheriff goes, Andy Griffith goes, What changed your mind?" "Well, I had to talk to Uncle Fred, and Uncle Fred said we just put you to sleep. There's nothing wrong with her. She just thinks there's something wrong with her. Kind of like my ex-mother-in-law. You know, you never ask her how she's doing. You ever met somebody like that? You say, "Hey," and that's it. You don't say how they're doing. Okay. Well, she had, what is it called? Not schizophrenia, but hypochondriac. The hypochondriac thinks something's wrong with them all the time. Well, she says the reason they're dying and the reason she comes by and get them every week is because of the sugar pills. And everything's in her head. Now, is that very true with a lot of things that's wrong with us? Yes. You can give a sugar pill to somebody that thinks they've got problems, and next week you see them, they're on top of the world, and they only take a sugar pill. A lot of studies have been made with sugar pills. Placebo is a very, very, very good word to have in your vocabulary, especially for standardized tests as well as my test. So make sure you have that one down. Capiche? Comprende? Comprendo, whatever. I don't do this part, so we're going to skip that. Retrospective. Go ahead and write down retrospective for your own knowledge. A retrospective study is when you go back and look at records of the past. Okay? You look at records from the past. Well, what the heck does that mean? Well, let's say I want to do how many people drive drunk in the United States, in South Carolina, in Anderson. How many people died drinking and driving in Anderson? Well, what am I going to have to rely on? I can't rely on future studies because you don't know when somebody's going to die for wreck with a drunk driver. So I have to look at what? Past. And when you look at the past, you're talking about retrospective. Retro means past. So make sure you know that one. That's not just for my test. That's good for any standardized test because they like that word on standardized testing. If you're taking a nursing test to get in a nursing program or trying to get a job at Michelin or whatever, that's a very commonly used word like random sample. Okay? Here we go, margin of error. Write that down. Margin of error is to go study is describe the confidence interval. How much confidence do you have in this poll? Now, where do you find the margin of error? It's at the bottom of the poll. It's usually in very small what? Letters. It'll say plus or minus 2%, or plus or minus 3%, or plus or minus 8%. Anything above 3%, the poll's not worth the paper it's written on. Okay? The lower the margin of error, the better the what? Better the poll. Okay? So if it falls around 0, it's good. If it's close to 10, not good. And of course, after 10, it's not even worth reading. Okay? So that's what a margin of error. The margin of error tells you the confidence in the poll. And that's 5A. We just went over 5A. Look in your outline. What's next? 5C? Look in the outline, please.
Yes.
Somebody tell me what page 5C is on. There used to be a little box you could type it in. But if it ain't broke, you need to fix it. If it is broke, you need to fix it, or you don't need to fix it. So they screwed that up. So now I got to hit this button until I get to what'd you say, 318, 319? 319. All right, 5C. Well, must be one. 5C, statistical tables and graphs. Frequency table, frequency distribution. A frequency distribution is a 25-cent word for a table. This is a frequency distribution. It's a 25-cent word per table that represents what? A head count. How many blondes, brunettes, and redheads we got in the classroom? I'm not even going to answer that because I don't know what colors what. I see 1, 2, maybe 2 blondes, 3 blondes, and then the rest I don't know. And me and one of 3 brunettes. I see 3 brunettes. All right, there's 3 brunettes. Me, you, and you. Oh, that's not okay. Blonde. I'm sorry.
So what did you say this is?
I don't. That looks like a strawberry Red.
Strawberry.
Red maybe, not strawberry. What color is that?
That's strawberry blonde, which is not red, that would be a dark.
My mom has red hair, so.
Yeah. That's not brunette, huh?
My mom's golden.
Is she?
Yeah, like, dark.
Yeah. Now she's a redhead, and then I don't know.
Strawberry blonde.
So, and that's a mix right there. So I don't know. So I'm just gonna say 3 brunettes, and the rest of y'all can figure out what y'all are. I don't know. I know what I am, and I know what these 2 are, and I see a couple of blondes, but the rest I don't know. So I'm just gonna say redheads and mix. Okay. But if I count 3 blondes, that's 3 blondes, and then 2 redheads, and then 4 or 5 brunettes. I just made a frequency distribution. Big deal. It's a table. Okay? Please don't get that confused. Half the time on a standardized test, they ask you for a frequency distribution, and half the time students won't answer it because they don't know what frequency distribution is, but they know what a table is. It's the same thing. Okay? The difference, there's 2 differences. There's a category table, and then there's a statistical table, like a class table. Class versus category. How many donuts do you eat? 1? Oh, you need to eat another one. I got all the donuts. I ain't taking things home. Category and class. Class is more quantitative, and category is more qualitative. Quality versus what? Quantity. Quality is quality, aspects of a person. Red hair, brown eyes. Okay? Versus quantitative data, which would be height, weight. Okay? So anything having to do with mathematical, what about Social Security number? That's qualitative. Why is that qualitative? That's a number. But does it mean anything numeric? No, it's an identification number. It's not a calculatable number. Can I take all your numbers and add them together and it means something? No. So therefore it's qualitative. Quantitative means that the number actually has a numerical reference to it, like a shoe size, or a weight, or a height. Those are numbers that mean something. A Social Security number means nothing. I could replace your Social Security number with your name. It's a category, all right? So that's qualitative data. Quantitative means class. Class means age, height, weight, shoe size, okay? Those are quantitative values, which means classes. Qualitative data means category. And a good one to use for an example, blonde, brunette, mid. Blue eyes. What is the number 1 color eye, period? Brown. It's dominant. Okay? What is the least?
Green.
Green. 2% of the population have green eyes.
So
Ain't
what
that
is
something? I didn't know that.
What is green eyes mean?
Huh?
What is green eyes mean? Like I know blue eyes mean just don't have that pigment in your eyes.
I don't know. You'd have to look that up. I don't know. I know that there's some people that's supposed to have brown eyes that come up with green eyes. Like there's this picture of this little girl, and she's very dark skinned, and she has like these green eyes, and it looks really, I mean, she's a beautiful little girl.
Like a hazel color.
Huh?
Like a hazel color.
No, they're green, like emerald green. And you've seen this, has been on social network, you've seen a picture of her, she's probably like 25 now, but anyway, just a picture of a kid, huh?
Some of that national.
Yeah, it's a National Geographic, yeah. And she's a beautiful little girl, and she's got dark skin, and she's got these piercing, like piercing blue eyes. She's got piercing green eyes, and it's just really, it just pops out because you don't see it a lot. And we all know brown-eyed people are more attractive anyway. So. Anyway, just kidding. Basic frequency table has 2 columns: category or class, and head count. Capiche? Okay, y'all just not gonna talk to me. We need to get into something more. I know, relative frequency is just frequency distribution, just about boring as you can get. I'm sorry. But if I talk about anything else, somebody will call my department head. If I talk about interesting stuff, people will complain. So we can't talk about interesting stuff. All right, we'll finish this up right here and we'll stop right here. Frequency, relative frequency. All right. Let's say that I go through and I pull, what's your last name? Solid. Okay, because I got to put you here. If I go through and I say we have three, oh, you're going to get a bit, oh, you're going to get one to go?
No.
All right.
Where's that?
Yeah, man. A while ago we said we had three blondes. All right. I think we're going to count him. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 out of 9 is what? 1/3. 0.33. So 0.33 is the relative frequency. Right now, relative frequency is x over n and equals to a decimal or a percent. X over n, which is equal to a decimal or a percent.
So what's the X number?
X is how many blondes, and n is always your biggest number, how many are in the class. So there was 3 blondes, I counted 3 blondes a while ago, and, no, 3 brunettes, I'm sorry, 3 brunettes, it doesn't matter. 3 over 9. There's 9 people in the classroom, 3 brunettes out of 9 is 0.33. So 0.33 is the relative frequency. Basically, you just put x over n. N is the total, the number of people. Always remember, write this down about n. N is always the total, it's always the summation, it's always the biggest number. It's always the total, it's always the summation, and it's always the biggest number. So the first thing you want to do when you do any statistics or probability is find n, or the relative frequency. Find n. So if I tell you in a class of 30 students there was 15 A's, find the relative frequency. What's n? 30. What's x? 15. Capiche? All right. Let's go ahead and stop for today. Why? Because I need to post the video and I need to call the roll and all that. So we're going to call it for today. And since we're not in the room that we need to be in, let me go ahead and address that. We will probably meet back. You just watch for signs. Until they fix 204, I don't know where we're going to meet. So we just going, it's going, me and you both or don't know. Okay, so when you come in,